Okay, so let's see. It is February 7th. No, we can't actually see that, though. February 7th. And just more stuff with our u-substitutions. More with u-substitutions. And before we get into the definite integrals that I mentioned we deal with, I do just sort of want to mention, not every composition problem will work with a u-substitution. U-substitutions don't always work. Sometimes we need some other methods for dealing with things. So I guess, what should I say? U-substitutions don't always work. For example, if I gave you the integral of x cubed plus 5 to the 6th, you know what? How about we make this x squared plus x cubed plus 5 squared dx rather than to the 6th? If we try u-substitution, Sydney, what would u be?
X to the third plus 5.
X to the third plus 5, sure. Caitlin Carson, if we did u is x to the third plus 5, what's du? What's the derivative of that? 3x squared dx. What's wrong? Anyone? You don't have the x squared. The 3 we could deal with, but we don't have the x squared. U-substitution isn't going to work on this. But I actually think we could still integrate this. How? I'll give you a hint. I changed it from a 6th power to a 2nd power for a reason. Although we could also deal with the 6th power, but it's nicer with the square. What can we do? You don't mean factor, you mean the other one. FOIL it. Yeah, distribute it. Just use some algebra to rewrite it, and then integrate. Go do it. Just for fun. And be happy I changed the 6 to a 2. On that test on Monday, there will probably be 1 or 2 integration problems kind of snuck in there with the u-substitutions that, no, don't require a u-substitution, just require you to use some algebra. So you just kind of need to be on the lookout for those things. This is totally wrong. That should be a 3. It's a dx. X to the 7th over 7 plus 5 halves x to the 4th plus 25x plus constant. How about the integral of x cubed minus 5x plus 2 over square root of x dx? How would you deal with this? U-substitution or something else? Elizabeth, any thoughts? Yeah, you can absolutely do that. What's the other way I usually do these things? We can also just separate the fraction. But again, we're just going to use some algebra here. U-substitution won't really do anything. Every year I have someone say, well, just make u equals x. Well, that's not like anything insightful. That's just changing what the letters. That hasn't made the problem any easier. Why don't we just separate the fraction, make it x to the 3rd over x to the 1/2, or do what Elizabeth said, just move x to the negative 1/2 up top and distribute that. That would also work. Take a moment, go through the algebra, and then integrate what you got. and then we'll get back to our u-substitution stuff. Should end up being, first of all, when you separate the fraction, should become x to the 5 halves minus 5x to the 1 half plus 2x to the negative 1 half. Then go integrate to 7x to the 7 halves minus 10 thirds x to the 3 halves plus 4x to the 1 half with your constant at the end. Once again, on your test, in the u-substitution integration part, I will mix in a few problems where u-substitution won't work. We'll see if you can use some algebra. Pretty much these are kind of the two main algebra tricks, some foiling, some separating the fraction. Be on the lookout for those. Any questions so far? Okay. What we really are going to talk about today with the new stuff, definite integrals. First example. I want to integrate from 1 to 4, x minus 1 to the 5th dx. I want to find the signed area under this quintic function starting from 1 going to 4. If you didn't have the 1 and 4, hopefully you would think this looks like a u-substitution problem. Caitlin Arsenault, if we were doing a u-substitution, what would u be? Sure. And if you did that, what's du? dx. So I think we could rewrite this problem as just the integral of u to the 5th du. That's nothing new. Here's the new piece. When I have these definite integrals, 1 and 4, those are x values, right? Problem is, I'm turning my problem into something with u's. I need the variables to agree. I need to change these x values into u values. Ideally, there would be like a formula that I could use to change x's into u's. What might that formula be? A formula that takes an x's and gives us u's. Do you see a formula on the board? U equals. We're going to use that formula to change our x value limits into u value limits. So here we go. When x equals 1, u is just going to equal 1 minus 1, or 0. And when x equals 4, u is going to equal 4 minus 1, or 3. What this is actually saying is the area under this quintic function that was moved right from 1 to 4 is the same as the area under just a regular quintic function from 0 to 3. Well, now let's figure out this integral. Antiderivative of u to the 5th, that's just u to the 6th over 6. And I'm going to fill in my limits of integration over there. So here's another place where this becomes a little bit different. 0 and 3. Are those x's or are those u's? u's, because that's kind of what I did over here. I changed the x's into u's. Therefore, I need to plug these in not for x, but for u. I'm not going to go and replace the u with the x minus 1 thing, because these are already u values. I'm just going to plug these numbers in and be done. I'm going to plug in, and I'm going to get 3 to the 6th over 6 minus 0 to the 6th over 6. Three to the 6, I don't really feel like thinking about this. Take out the calculator, type it in, that's fine. No, on your quiz, I'll make the number smaller. The end is really easy. The end is just minus 0. Marley, what do you have? 249 over 6, minus 0 at the end. So we're going to get 243 over 2. Yeah, I will keep the numbers a little more manageable for a quiz. All of our u-substitution work is the same as last time. We will have to deal with the multiplying inside by number, outside by number. I'll show you one of those in a moment. The new steps are those limits of integration that are x values. We need to change them into u values. And then, once we've integrated, we're just going to plug in those u values where we have the u in the answer. Let's do a couple more. Let's take a look at, for example, the integral from 2 to the square root of 23. I promise it's going to be okay. Of x times the cube root of x squared plus 4 dx. It's actually a good thing I have the square root of 23. You'll see why in a moment. I'm going to integrate this thing from 2 to the square root of 23. So we'll start with our u-substitution ideas. Sydney, what's u?
X squared plus 4.
So what's du? Sydney again. 2x 2x dx. So Elizabeth, how can we make this work? I want 2x dx. I just have an x dx. Absolutely. Stick a 2 inside, stick a 1/2 on the outside. This is now 1/2 times the integral. I'll deal with the limits in a moment of the cube root of u du. Change your limits of integration. Same way we did in the last problem. They're x values right now. Change them into u's. Go use that formula.
Why did you put the 1/2 on the outside of the integral?
So I want a 2 inside. Are you okay with the 2 inside?
Yes.
Problem is you can't just do that. You can't just multiply something by 2. I need to cancel it out, so I'm actually just multiplying the thing by 1.
Okay.
I think we should be able to turn the 2 into an 8. Plus 4 is 8. And the root 23 into a 27. I hope. Does that make sense? Integrate. When you're done, are you going to replace the u with x squared plus 4? No, we changed those limits of integration. So integrate and then just plug in your 27 and 8. See if you can do this work without a calculator, because I think this one would be fair for your quiz. Go integrate. thought it would be easier just to kind of move the 3/4 up front and just deal with a single u to the 4/3 than like some fraction inside there as well. So I just said 3/8 times u to the 4/3 from 8 to 27. Marley, the final answer? Good. So what was 27 to the 4/3? Cube root of 27? Anyone? 3 to the 4th? 81. We're going to get 81 there. 8 to the 4/3? Anyone? 16. Cube root of 8 is 2. To the 4th will give us 16. So we should get 3/8 times 65. 65 times 3. 195 over 8. Are you following how this is working? Well, let's see. Oh, sure, we need to do something with trig. Let's try the integral from pi over 4 to 2 pi over 3 of the sine of 2x dx. There we go. Integral from pi over 4 to 2 pi over 3 of the sine of 2x dx. See what you can do. Does this look okay for the rewriting stuff? 1/2 times the integral from pi over 2 to 4 pi over 3 of the sine of u du, I hope. The integral of sine u cosine u or negative cosine u? Negative. Oh, good. Keep going. Caitlin Arsenal, what's the cosine of 4 pi over 3? Any other thoughts? Caitlin Carson? Negative 1/2. You are just short of horizontal over there. I want the x value, negative 1/2. Elizabeth, cosine pi over 2. Sine the area under this thing is 1/4. Do you get the basic idea of how this is working? Maybe more the people who were also here yesterday. So, first of all, let me stop this. That's all there.